Very good morning. Hello. Hello. Hello.
Hello, sir. I'm
Yeah,
here only.
I'm audible to you, sir.
Yes, sir, you are audible.
Yeah. Welcome back in this second day.
Thank you, sir.
So we will start at 11:30.
Perfect.
Good morning, sir.
Okay, so very good morning to all of you. Myself, Himanshu Swarnkar. So welcome back in this 1 week STTP on artificial intelligence and machine learning. Today we have a resource person with us, Dr. Abhishek Pandey, Abhishek Kumar. Dr. Abhishek already taken expert lecture yesterday. Today we have the second lecture. He is associate professor in Department of Computer Science and Engineering, Chitkara University, Punjab. So welcome you again, sir.
Thank you so much, sir. Thank you. It's pleasure.
Shall we start the session?
Yeah, we can, sir.
So session
Should
is yours, sir. Welcome.
Okay, sir. Should I start it?
Yes, sir. Please.
Okay, sir. Okay. Thank you. So let's start the session where we have left yesterday. So we have to start from there only. So I have discussed in yesterday's session that we will go through with machine learning and AI concept first, and then we will go through with what image processing is all about in medical image processing. Fine. So it's not about only theory and concepts, but we can touch the practical aspects of it in tomorrow class. Fine. So we will do the labs and practicals on MATLAB tool. And I will tell you something about MATLAB and prerequisites, that what we will have to go through with one by one in the last of this particular session. So we need to clear some basics and what is going on right now in medical image processing. So it is very much relatable to artificial intelligence. It is actually artificial intelligence itself. So let's have some figure that what is going on right now and what impact medical image processing has left on society as far as artificial intelligence and image processing is concerned. Fine. So let's move to the slide. So this is the medical crisis. So that definitely need AI. We have discussed about telecommunication yesterday, if we have remember. So right from, this is the data from USA to Germany to China to India. So the blue line is for USA and India. The dark line is for India, and the black is for Germany, and the red is for China. So you can see the differences, and you can see the growth and downfall. It is a data which has been taken from WHO. Fine. So this is the WHO, I mean, global strategy on human resources for health. Fine. So workforce. So it would be like something will be done in 2030 reports. I mean, Fine. So there is a result that there is a shortage for sure. And it can mount up to 9.9 million physician, nurses, midwives globally by 2030. Even if we will go in hospitals in Indian scenario, so we will see the deficiency, we can see the shortages. Fine. So what happened? We have not to rely completely on AI, but somehow telemedicine, biomedical, bioinformatics, these things are there. So it is something which is, very much making the patients and making the people relaxed. Fine. Even if in the case of Corona, so bed and every other material has been managed at very short notice in China, Wuhan. Fine. So all automated everything was done or patient has been checked in automated way. Fine. So that they cannot, communicate their disease to other person. So these are the cases where it all starts from. Fine. So we don't have enough doctors. Fine. So there are lots of survey reports which I have been depicted in there to provide a base for our today's discussion. Fine. So these are one of the thing. This is the second, survey report, which include Indonesia, India, South Africa, and various other countries all around the globe. Fine. So we all are, the basic of this thing is, we all are, all continental and subcontinental countries, they all may facing a shortage of, millions of health professionals. Fine. So WHO and other health organization, which is a global organization, they all thought that we could proceed with some image processing, AI, machine learning concepts, which can bring about some change in health scenario to make it intelligent healthcare. It is no more a healthcare, it becomes intelligent healthcare. And how it become intelligent? I have told you that learning and training will make it intelligent. That's how we can domesticate our dog. That's how we feed a child with a spoon concept. Fine. So we have to make them learn, we have to make them trained, and just like a model. Fine. Similarly, so these all are data only. How many students had been registered as physician and how many have crossed that data. Fine. How many are eligible to, cure you or able to, diagnose the things, what is the real problem is. Fine. So medical crisis is, very common to me, to you, to all of us. Fine. And it's not in India. In India, it is exceptional, but all over the world, it is. Fine. So it could be like the first point is there is, you can see dependency and ratio increases, not enough money. Fine. More and more aged people. Fine. The third one is not enough doctors. Third, and the fourth one is few wants to become a doctor. So worry about healthcare is still an issue. Fine. So how we will overcome it, how we are planning to overcome it, these are some issues which we are going to discuss. Fine. So, the primary level of discussion is whether AI can, whether it can cut the medical cost. It is. So if it can cut the medical cost, it will definitely improve the work efficiency that we have proved in the discussion yesterday also. But what we reach at in yesterday discussion that we cannot replace a doctor's work. No, not in coming 20 or 30 years. Fine. So standardized the treatment of patient, that is definitely doable with the help of intelligent healthcare, with the help of artificial intelligence. Fine. But AI doctor preferred, the answer could be no. At least as far as my personal view is concerned, it's no. Fine. So these are some discussions which can be proceeded. Fine. So medical imaging, fit for AI or not? MRI is there, CT scan is there, tuberculosis analysis is there. Fine. Medical diagnosis is there. So these all are the image processing applications, which is ultimately a branch of artificial intelligence as well, because we are making the things automated. What machines can do, but humans cannot. That is AI, what we have discussed, what my definition of AI is. Fine. So the point is, when there is a cost increase, so MRI, and it is not affordable for each and every family as far as India is concerned. Leave about, US and Germany and France. Fine. So it becomes relatively simple. That is the first point. And the digit data make a very easy analysis for doctor as well, that they will reach at some decision. So this is a decision making concept. So we have to rely on some decision making algorithms. The third one is relatively standardized data collection. If we cannot proceed, or we cannot reach at some decision by taking 10 or 20 patients, we have to go through with bulky data. We have to deal with bulky data to reach at some decision. So standardized the data collection is very much important. I have told you when we were discussing SVM, if it is linear model and it is supposed to perform data analysis on non-linear data, so it will be a problem. The result will won't be efficient enough to go forward with. Fine. So there is a concept of big data as well. So big data is actually a platform, but how you are managing it and how you are performing it by using different mining and machine learning algorithm, that is debatable. That is a different scenario. That is a different dimension we have to work on. Fine. So this big data is a very much revolutionize these things, that data collection, and analyze those data in a very much efficient manner, and to reach at some decision by taking some complex data, some bulky data that came from MRI and CT scan and different patient data. Fine. So big data is very much important in that way. But we are here to focus on medical imaging fit for AI or not. So it is very much fit and it is doing very much good. But it is, current generation. AI is the future generation, but this wing of AI is the current generation. It is getting used here. But there is chance of discrepancy in it also. It cannot be, perfect. No machine can be perfect. No human can be perfect. That's the same case we have to go further with. So what happened when I was searching for some matter to get discussed, I got this, that the President of Radiology Society of North America, fine, Vijay M. Rao, from an Indian route. So how emerging technology will empower tomorrow radiologists to provide better patient care. So she has given us very good representation where she has talked about the emergency technology, emerging technology that will empower the radiologist. So radiology is, very much important in better patient care. So it is a very much used as milestone in different papers and different research work further with. Fine. Similarly, Professor Michael from Artificial Intelligence Analytics and Informatics. So he told that the future is here only. This is the future generation, which has been talked about from long time ago. But he has given some different views about Alexa and Siri and automated car and different other things. So these two people, their talk and their article, which has been published, has been phenomenal and has been a milestone throughout for the researchers. Fine. So that's why I have discussed their name. So this is something about the different analysis, different number of papers, different number of articles, different number of research that has been proceeded and that has been published in Web of Science journal. In artificial intelligence, you can see the number up along with the year of the publish. AI with medical, you can see the number. It's less than artificial intelligence completely. And AI with imaging, it is as same as AI and medical. So image processing and AI can be said, two sides of the same coin. Fine. So basically, here we are starting from what medical information, what is medical informatics research? What is medical informatics basically is? So we have to go through with this one by one. So let's discuss it. So what medical informatics is? What they're written in your PPT, which is appeared to you, is very much simple example. We can get it from net also, that it is the application of computer communications and information technology. But I want to make focus on something which is very much important. So I would say like medical informatics is a sub-discipline of health informatics. Remember it. It is a sub-discipline or sub-branch of health informatics. Fine. That directly impacts the patient-physician relationship. Whether it is physician, whether it is surgeon, it is not important. So I am just telling the patient and doctor relationship. Fine. So basically, the primary reason it focuses on the information technology that enables the effective collection of data. I have just told you what is the standardization of the data. So effective collection of data is very much important. So using technology tool, fine, to develop medical knowledge and to facilitate the delivery of the patient medical care. So it is very much important. Now getting my point. So whether it is medical care, whatever there is in your PPT, whether it is medical education and whether it is medical research, fine. So it is a reference from a person, MF Colleen, medical info. He has quoted this in 1980. But what basically decision is there? So basic decision is, what is the goal of medical informatic research? So the goal of medical informatic research is very much important as far as image processing and medical image processing is concerned. The goal of medical informatics, we can say, is to ensure access to the critical patient medical information. I have told you yesterday that we can solve any kind of less complex problem manually. We need not to, spend money and manpower over it. So we need not to go for algorithm. The same concept will be followed over here also, that we have to solve only critical patient medical information. Apart from, simple information can be done without using, any AI concept, any AI technology, any machine learning technology, anything. Fine. So critical information at the precise time is very much important if medical informatics research has to be done. Fine. And it should be placed, it is needed to make medical decision at the right time. So to solve those bulky data, to solve those critical information, we need actually what medical informatics is all about. Fine. So in a single line, the last line I would like to add into it, that medical informatics also focuses on the management of medical data. Getting my point? So medical informatics या information technology की जब हम बात करते हैं, या medical informatics की जब हम बात करते हैं, what is it dealing with? A technology which is dealing with the different information. So medical informatics is what? Medical informatics focuses on the management of medical data. If somebody is asking you in a single line, you can say that it focuses on the management of the medical data for basic research, standard research, and education. So to deal with the management of medical data for research and education is medical informatics, a single line answer. Fine. And how to get it? So it can be gettable through AI concepts, AI technology, machine learning technology, and so from the technology which is called image processing or medical image processing, whatever you want to call it. Fine. So I hope this is clear to everyone what medical informatics research and what is medical informatics all about. Now, the same thing is, what is medical informatics in this way? Fine. So what I have written is a code which has been developed from 1980 to 1997. So now what is the definition which has been changed with the time? So the definition is, medical informatics is the branch of science concerned with the use of computer and communication technology. It is as simple as that? No, it is not. Fine. So to combine the computer and communication technologies, fine, to acquire knowledge, to gather information, to display medical information and knowledge. So to display medical information and knowledge is not the primary thing for now. To gather it is the primary thing. And how to manage it is the secondary thing. And how to facilitate the understanding and improve the accuracy is the tertiary thing. So there are three things basically. Fine. And how that decision can be reliable? Can we rely upon those decisions? So these all depends upon the collaboration. And what collaboration I have talked about? Directly impact the patient and doctor relationship, that collaboration. That how the technology is getting tackled or getting managed by the technician, and how the synchronization has been processed between doctor and technology and or technician. This is the thing which will make the things that use of computer and communication technology. So it is a vast thing, but it is summarized in a single line. Getting my point? So how the things has been changed? I'm going to the previous slide. Just see application of computer and communication. Nothing has been changed. Again, the computer and communication technology, but there is a change which is called acquire, store, and communicate. Fine. So data is getting bulky day by day. We are getting bulky amount of data to process it further with. Fine. So now the point is how we will make the decision making. I mean, how the decision making can be improved as far as AI, image processing, and machine learning is concerned. Decision making is one of the most important steps. So we are all involved in decisions in life. Fine. So we are taking examples from real-time system, from a simple to complex. Fine. Those that deal with, patient and client, to those that deal with our life outside work. Fine. This could be one of the example. Then decision making can range from fast, having some logic, or some intuitive, without some logic, but some, extinct, that by intuition, I'm telling you that this work is going to be done very shortly. By intuitionally, I'm telling you that this, long hour. Fine. And other alternatives could be like heuristic approach, probabilistic approach. This may be done or may not. These all are decision making. How we will collaborate this decision making or synchronize this decision making with the clinical approach, that is the case I want to discuss. Fine. So when we are talking about heuristics decision through the well-reasoned or analytical or evidence-based decision, heuristic. But when we are talking about probabilistic, it is, a vice versa. Fine. So there is a point, there is a spectrum of decision making. At one end of a spectrum, we use our intuition and experience, past experience, just like weather prediction, stock market analysis, where there are typically high volume of, simple decision to be made, high volume of data, and we have to make a simple decision out of it. So at the other end of a spectrum, there may be complex decision to be made. Whatever I have discussed is for simple data, not about bulky data right now. But when we are having bulky data on the other side of a spectrum, where the level of uncertainty is high, then what we will do? So there we will definitely need an analytical and evidence-based approach, heuristic only. Probabilistic approximation approach, it will not work there. Fine. So we need some evidence-based approach to support the rule-based heuristics or experience also. So this can be done by using the experience or using the past data we have worked on. Fine. So whenever we are talking about clinical decision making, we have to make sure that we need not to be ambiguous. We need not to be ambiguous. That means we have to be specific, because a single data misinformation will create a critical issue with patient. Getting the point? We have to be complete enough, and the data should not be poorly organized. So these are the things we have to focus on when we are talking about clinical decision making. So by taking the base of AI and machine learning, but we are getting it implemented or getting it synchronized with image processing or machine learning with clinical approach. Fine. So what is the problem? When we are talking about clinical decision making, I have talked about the problem also, that it may be the quantitative, it may be the qualitative. Fine. So if there is any misinformation, any bit of misinformation, it will create a very critical problem. For example, I have given in the slide that army officer and pilot commit fatal error. Fatal error means hard real-time system, which cannot be recovered mostly. So when given too many or too few or poorly organized data, the same is true for clinical approach also. Fine. They don't have the second chance to proceed further with. So susceptibility is the, primary feature, how they adapt to the condition, how they adapt to the technology, and how they are getting the best result, optimum result from the technology. Fine. After omitting the errors. So these are the things which need to be considered when we are making some clinical decision. So if we consider this concept with the particular decision tree or decision making, we are getting it connected. That we are using that decision making concept, that suppose we are having an example that whether this person is having age more than 45, he will get around 50,000, and whether he is having age of below 45, he is getting 45,000 to 40,000, something like that. So it is a very simple logic and very simple concept any industry or company is following. What we have read in the basics of decision making process, decision tree, random forest tree, we are reaching at something by using classification and prediction, by using the past data experience. And the same would be prefer over here also. But in clinical, we need to perform much better and much, because a simple misinformation can create a fatal error, a real-time, hard real-time problem. Fine. Then there is a thing which need to be considered, that non-perfectionist of dimension of humans. Fine. Whether it is for data processing, so better performance require more time to process. Fine. But if it is clinical approach, so productivity will always create a problem when it is a clinical approach. Fine. Because data is bulky. So the administrative task will be increased in a same context. Fine. So whether you are, detecting some tuberculosis, or whether you are detecting some static cyst in any image, or whether you are doing some X-ray or some MRI scan or some CT scan, and if you are processing it on any tool, whether it is Python or whether it is MATLAB or whether it is OpenCV, they are worked on the past data or the data is stored there. So still the question is, it is a wing of AI which is in current state, but AI itself, it is in future state. It's in, will be work in, coming 20 or 30 years. That's my point is. These are the subdomains of medical informatics, and I have taken it from Wikipedia. So first one is image informatics, and then there is a clinical informatics. In clinical informatics, there is nursing informatics as well, or you can consider it a solo concept apart from this. Apart from this, there is a consumer health informatics. Fine. Whether there is a company which has been launched their app, or healthcare company, or they are making healthcare devices. So that is public health informatics and consumer health informatics for you. Fine. The same concept will be elaborated with dental informatics, the subdomain. Then there is a clinical research informatics, which is different from the domain. Fine. So there is more like some incurable disease like cancer, Alzheimer. These are under, these are being analyzed under the Research Informatics Center. Then there is a bioinformatics and the similar pharmacy informatics. So these are the different domain of the same image informatics and clinical informatics concept, medical informatics concept, which can be traversed or which can be explored through image processing. And the platform could be anything. It could be like Python, it could be like MATLAB, or it could be like anything. But these are the subdomains of medical informatics. Fine. Now, these are the subdomains of medical informatics and how we will explain it. So we can explain it that medical imaging refers to a technique, fine, and processes used to create image of various parts of human body. Fine. It is not very specific to some part, upside of the waist or below the waist. It could be like any part or various part of human body for diagnosis, for treatment purpose, within a digital health. Getting my point? So the term basically we have used, medical imaging, so include various radiological image techniques, such as we can take X-ray radiography. First of all, X-ray radiography में अगर आपके पास data set अच्छा है, तो we can go ahead with the image processing, or we can upload or load the data into the tool and we can analyze it very efficiently. For example, I'm giving you a real-time example. There is a similar cases when we are analyzing test cases of corona and pneumonia. So we are having data set on GIT hub and we are about to process it. So there is a very, less difference or threaded line difference between the symptoms. Or when you are analyzing the pneumonia patient X-ray or heart X-ray or corona patient heart X-ray. Both are having the same symptoms. Both are having the same output when we are analyzing it. So X-ray radiography is very much important. Then there is a fluoroscopy, MRI. MRI is magnetic resonance imaging. It is itself, there is a name called imaging. So medical resonance imaging, MRI. इसके लिए एक अलग टूल भी जो है वो MATLAB अब इन दोनों प्रोवाइड करने लगा है medical image processing के लिए. Fine. Then there is ultrasonography or ultrasound, you can say. The other options could be like endoscopy, elastography, thermography. Fine. So medical photography and nuclear medicine function, whether it is imaging technique, fine. That means positron emission tomography, PET technique बोलते हैं उसको. Fine. So we are getting it from that particular image, the information we are required to get. Fine. So what basically we are doing, it also included in medical imaging, whether it is measurement or whether it is recording technique. So don't create image, but produce data. Image processing is not working on image, but it is working on the matrix. Fine. So if it is working on a matrix, it is working on a data itself. Fine. And it will produce the data only for the doctors to go further with. So that's why it is often represented as graphs on map. Fine. किसी image का graph जो है वो आप नहीं बना सकते. आप बनाते हो किसी data का या किसी digit का graph. Fine. So we are getting in that way. So person with technology better than person without support. So this is the main concept. And it has been done from National Library of Medicine. You can see it. Fine. So this is all about the subdomains of medical informatics. So now here comes what is medical imaging. Fine. So what is imaging basically is when we are dealing with image processing in MATLAB. So to deal with image, even to study or to play with 2D or 3D image, to represent it any 3D images in 2D manner is called image processing. To deal with this X coordinate, Y coordinate and Z coordinate on a 2D screen is image processing. To digitalize those images or to extract those information from those images is image processing. So the study of medical imaging is concerned with the interaction of all form of radiation and tissue. Fine, what written here. And the second point is, so appropriate technology need to be collaborated with the clinical things, providing the useful information and display image in a digit form, and later it can be observed by the person who can analyze this thing which has been done with the technology effect. So this can be more relatable. What is image processing and what is medical image processing? There's nothing difference in that. It is the basic difference is to provide the data which is associated with medical, to have medical data sets and to operate it on some tool which has been used for operating other images is medical image processing. To get digits or to digitalize or to get information out of the image or any medical image, whether it is MRI scan, whether it is CT scan, whether it is X-ray, is called medical image processing. So the question arises whether image processing and medical image processing, single difference is when we are working on medical data or we are uploading medical data or getting some information out of it is medical image processing. Of course it is. Image processing is a wide domain and medical image processing is subdomain of that image processing when we are dealing with the different medical data sets. I hope the concept is clear. Fine. So we have taken the data set from these places. Positron emission tomography, I told you. CT scan, I told you. MRI, I told you. Magnetic resonance imaging. Fine. So here we have written the first line. If you will write, the study of medical imaging is concerned with the interaction of all forms of radiation with the tissue. Fine. So what data or what information will be, generated there will be huge, large, bulky. So to deal with those data, we need some algorithm, we need some technology, we need some tools to deal further with. We cannot do it manually. That's where medical image processing comes into the picture. Fine. Examples of medical images, some broken fingers or some broken bones from, we have taken examples of hand, palm, or fingers. It could be anything. So once we have taken a very, normal images or X-ray images, and then we are getting it to be discussed on some tool. That is medical image processing. So the point is, here we are doing some tomography. And these all things can be done, not in a very expensive manner. It can be done in a fraction of a second and in a very efficient manner. Huge computational things will come to you in a very short span of time. And you are able to analyze, or any doctor or any physician or any surgeon can able to analyze the things in a very depicted manner, in a very explained manner, in a very explored manner. That cannot be done with the simple machines as well. Fine. So we can discuss the different dimensions of the same medical images, whether it is oral cancer, whether it is heart disease, whether it is fracture. Fine. So we can do it from all the different aspects, whether it is tissue analysis, the last image is, you can see that. So right from simple analysis to tissue or cells analysis, everything can be managed through a tool. Fine. So this is imaging chain. What we are doing here, if you can see, there is a raw data in form of Excel, we can say, in form of image or clicked image with some good quality camera, we can say. So raw data could be anything. It could be probe image, it could be probe data. So we need to filter it. Just like, कैसे filter करेंगे? जैसे अपन कोई कभी पानी लाते हैं तो एक purifier के through हम उसको पीते हैं. पानी लाते हैं, then we put it into purifier and then it will filter out the pure water for you. So whatever impurities are there will be removed. And what is impurity? What is noise for us? Can we discuss it? What is impurity and what is noise for us in the whole scenario? Anything which is not intended is noise. Suppose we are having 10 people in a same class, same room, and everyone is talking their own local or regional languages, whether it is or whatever the language is spoken in their countries, like Japanese, like Chinese, or like Hindi or English. So everything is noise apart from their own language, because they don't understand that what Chinese is, and what Japanese are not understanding what Chinese is, and Chinese are not understanding what Japanese language is all about. And Hindi people and or Indian people will not understand what Chinese is. So everything apart from the intended value is noise. If we are adding 3 plus 2, it has to be 5. If it is giving 5 plus 5.5 or 5.2, 0.2 is noise. We are not expecting it. We have to precise it. So what raw data we are having could be having many other attributes which is not needed. Suppose we have to analyze, a malaria patient data. So we don't need if there is any fracture happened to that person or not. So it is a filtration of data. So the first process is filtering the data. It is also said pre-processing, what we have gone through in data mining. Excuse me. Is my PPT appearing?
Yes, sir.
It is not appearing this way. I'm sharing it again. So here we are. Fine. So there is a pre-processing and there is a processing. Two kinds of things are there. Okay. So two things are there, pre-processing and processing. So once it is being pre-processed, it is being filtered. Now the raw data is, has been gone for reconstruction. Fine. In reconstruction, each detail, like we have gone through with the concept, variance and covariance when we were in 10th or 9th class. Fine. So how much data is getting deviated? I'm giving you an example. Suppose you are having a data with the concept like a data with having x coordinate is 2, y coordinate is 2, and z coordinate is 1. And suppose other person is having the same data with x coordinate is 3, y coordinate is 2, and z coordinate is 0. So when you will sum that data, you will get 5. Fine. And suppose it is a facial information or it is some clinical information. So can we move, अगर मान लो दोनों का सम जो है वो 5 आए, तो क्या ऐसा हो सकता है कि दोनों की बीमारी भी सेम ही हो? So we are basically based on some perfect results and on. So there is a concept of how much data is getting deviated from the centroid position. Now what we have to do, we have to sum those data and get the deviation by taking the bar. So what is the bar? It is the average of those data. So when it is 5 by 2, when it is 5 by 2, both are having the same average as well. But we are not reaching at some decision that both are having the same deficiency or both are having the same disease. Then what we will do? We will take the deviation. We will get the concept of variance and covariance. So what is variance? Variance is for 2 coordinates, x and y. Covariance is for 3 coordinates, xy, yz and xz. Getting my point? पहले आप कोवेरियंस निकाल लेते हो, फिर वेरिएंस निकालते हो. अगर मान लो कि 3D डेटा है तो आप उसका कोवेरियंस निकालते हो. पहले xy कोऑर्डिनेट का, फिर yz का और फिर xz का. गेटिंग माय पॉइंट? अब जो है वो कभी भी डेविएशन सेम नहीं आएगा. यानी xi जो डेविएशन आया सेंट्रॉइड का, यानी 5/2, उसमें से जो उसका एक्चुअल कोऑर्डिनेट है उसको आप माइनस करते हो. दैट इज 2 to 1 and that is 3 to 0. Now the difference will always remain like that. We cannot make those information similar. Those are very much different from each other. So these basic things need to be covered because these are the things MATLAB or Python or OpenCV will prefer to do when you are importing images into it. Fine. So this is the concept of reconstruction, to getting all those coordinates into a single matrix. Fine. Now there is a signal acquisition when it is being done. So how it will be done? So it will be processed and analysis, and then there is a quantitative output. Quantitative output means having some logics, having some digits information. So you can see in the quantitative output, we are having something in a number. We are having a matrix. Row wise or column wise, you can analyze it. It will give the same result. Whether you are going through with row wise or whether you are going through with column wise, it will give the same result. Getting my point? And finally, everything will be done. Then the output will be generated as per the data we have imported into the tool. So computer basically understands 0 and 1, and this game is all about 0 and 1. Getting my point? Even if you are importing images into your MATLAB or any other tool, it will convert it into 0 or 1 thing. Otherwise, MATLAB will never understand what image is all about. It is getting information from that image and process those information and getting the output. That's what the system is all about. taking input, process them, and getting you output. That's it. Fine. So the basic point is we have to consider, we have to, understand what filtering is, what reconstruction is, what is pre-processing, what is post-processing, or simple processing, you can say, how it is analyzed, and how quantitative output can be generated for signal acquisition. Fine. So this is all about the imaging chain. So let's move toward the next section. So the next section is image analysis, turning an image into a data. I have discussed a little bit about this, that how image can be converted into data. Fine. So image analysis, also known as computer vision, which is the next topic to cover, or image recognition, we can say. So how it can be explained? In simple language, what my definition is, it is the ability of computer to recognize the attributes within an image. Fine. And how those attributes or those features, यहाँ पे जिस feature की मैं बात कर रहा हूँ, that features is there in exam level and finding level. Fine. So if we have to find feature 1 and feature 2 out of 3 features, feature 1, feature 2, feature 3, so we have to use the image processing technique, and how it can extract the qualitative and quantitative features. It is depending upon the situation, or it is depending upon the parameters, or it is depending upon the algorithms, different algorithms, what it is based on. Fine. So what basic need is turning an image into data. If you are loading an image into your tool, you are getting it converted into matrix. And matrix is all about data. It is all about number. And computer always understand 0 and 1. So the point is, suppose, do you use Google Photos or Apple Photos app on your smartphone? Google Photos app can be used by everyone. Everyone can relate to that. Fine. So they both use some level of, Google Lens is also, you have heard about it, or you have, gone through with it, how Google Lens work. So they both, or they, all the three, use some basic image analysis feature to recognize face and categorize them into, your or my photos. So you can, look at all your photos of a particular person. For example, if we are typing dog into a search function, fine. So within either app to quickly locate your collection of puppies photo, or type beach, B-E-A-C-H, to find the, tropical vacation pics. Anything you can go further with. Fine. If you are coming to Facebook also, so social media analytics is started with and continues to be based on text analysis only. Text analysis, sentiment analysis, these all are the things which are the base for social media app or social media websites. But the image analysis is becoming very much important nowadays. So when applied to social media analytics, image analysis is the extension of text analysis. Remember this. Image analysis is an extension of text analysis. And it can be applied to the visual content. The same method of categorization applied to image analysis. Fine. चाहे आप ये वाला अभी जो next वाला है इसको अभी रहने दो, ये वाला देखो. ठीक है? We are having 3 features, suppose from the same image which has been depicted on your screen, and we have to find 2 features out of it. How it will be done? So we have to gone through with filtration. We have to work on the raw data. We have to reconstruct it to convert it into some digit. We have to analyze it and get the answer in digit. That's what we have done. Fine. That's why I have said that the same method of categorization, we are categorizing the things to apply to image analysis. Instead of looking at all the post, all the post or features, there is a grid in the image you can see. If it is able, if you are able to see, there is a grid in the image, so that the different posts of that image or different grid of that domain of the image can be seen. Fine. So if you are supposed to done object recognition, you have to go through with all the domain of that grid that contain photos of, that particular thing you are supposed to analyze. Fine. So suppose you are providing a mask to this image on some area 3x3 you have written. So it will done on third row and third column, that area also. I'm moving the cursor there. See, first column, second column, third column, first row, second column, second row, third row. Fine. So this area will be covered only if you are providing mask to this. Fine. Similarly, what area you want to cover, what threshold you want to cover, you have to provide that initially as a global variable in your example. Fine. Now the major advances of medical imaging. क्या-क्या चीजें हैं जो नई-नई ऐड हुई हैं, उसको अपन देखते हैं. तो पहला है image segmentation. Fine. Small image segmentation level has been depicted here. The grid on and grid off is image segmentation process to particularly focus on some specific part of that particular image or domain. Then there is an image classification. Then there is a CAD system, the same computer aided design. That computer aided design has been changed to diagnosis or diagnostic. Then there is a computer aided diagnostic characterization. Very minute information if you want to extract from your image, then you should go for computer aided diagnostic systems. Then there is a content based image retrieval. Suppose you need to get some texture recognition, some texture retrieval. We can see it when we will perform examples on MATLAB tomorrow, most probably. Then there is image annotation. Annotation means stitching the different images from different source or from different analysis and to reach at some decision. So we need to annotate that particular image. So these major advances can play a major role in early detection or diagnosis of some uncured disease, whether it is Alzheimer, whether it is cancer, whether it is any kind of other things. So treatment planning in cancer and radiation therapy, it has also been depicted here. Fine. So these are some major advances. Apart from that, let's come to discuss what is computer aided diagnosis or design. Fine. So it is very much simple. This computer aided design we have gone through with previously as far as we are engineering students. So what diagnosis is all about is diagnosis made by a radiologist. Fine. So when the output of computerized image analysis method has been incorporated into his or her medical decision making process. I'm explaining you in a different way. Then we will discuss the line just below it. Fine. So in medical image field, basically computer aided detection or computer aided diagnosis is computer based system. क्या है ये? ये एक simple computer based system है. And what is the work of it? That helps doctor to take decisions swiftly, very much efficiently. So medical imaging deals with information in image that the medical practitioner or doctors has to evaluate or analyze different abnormality in a very short span of time. Time complexity is still mattering. Getting my point? So analysis of image in medical field is very much crucial task. Fine, it is very critical. Image is, having the basic modality to diagnose any disease. So if we are diagnosing any disease, so at the earliest we want to diagnose it, we need to prefer computer aided diagnosis. Getting my point? So whether it is image technique like MRI, X-ray or endoscopic, ultrasound, whatever we have discussed more than 7 or 8. So CAD system are having, it has been used to improve the quality of image, I told you, right? And if the quality of image has been improved, or if the image has been pre-processed, if noise has been removed, it is very much efficient to get a very good analytical result and to reach at some decision which should be retained for a long time. The doctor can the doctor can rely upon that particular decisions, which helps to interpret the medical image correctly. Getting my point? and process the images for highlighting the conspicuous part, which has not been done, manually. So it is basically a technology in which we can say, which includes process the images for highlighting the conspicuous part, complex parts. So it used the elements or AI, computer vision, and medical image processing. All three are coordinated and synchronized for providing computer-aided diagnosis. So let me discuss the main application of CAD system in finding abnormality in the human body. If you have remembered, you have gone through with the outliers detection. That is the main concept which has been, which has been used in computer-aided diagnosis. So among all these, detection of a tumor is a typical application. It is very complex application because if it misses in basic screening, it leads to cancer. So how much we can rely upon medical diagnosis through AI or image processing? It has to be specific and precise. Fine. So basically CAD is used in the diagnosis of breast cancer, lung cancer, fine, bone cancer, artery diseases, heart defect, Alzheimer, I have told, and different diabetic renotherapy we have also used. I have been working on diabetic renotherapy right now with one of my PhD scholars. So we are using it, computer-aided diagnosis through different Python and MATLAB, both. Fine. So there are different concepts. So now we are moving to the text written right down there. CAD may be interpreted broadly and incorporate both the detection of abnormality task I have discussed and the classification task. And the classification task will always based on the livelihood or nearest neighbor approach. That is, abnormality represents malignancy. Fine. Outliers detection jisko bolte hain. So these are something which need to be taken care of. What motivation of CAD system is there? This could be also done. See how a particular area has been retrieved with some digital information, whether it is in form of matrix or whether it is in form of digits. So it could be like D1, D2, D3. It could be like distance vectors. It could be like feature vectors. Getting my point? So basically, what texture classification is all about, it is a problem of distinguishing between texture, a classic problem, in pattern recognition. Getting my point? We are actually doing pattern recognition. So since many very sophisticated classifier exist already, so the key challenge here is the development of effective features. Fine. Effective informations to extract from a given texture image. So there is an image in the first slide, in the first image, it is a probe image, and we are extracting some features in the second image. Fine. But there are many approaches that has been defined to extract features. For example, Gabor filter, ye ho sakta hai, wavelets ho sakta hai. So how we will overcome those great deal of recent work? Patch based method use kar sakte hain. So whereby the texture is classified strictly based on set of small patches of pixel extracted from given texture image. That's what we are doing in the first step and in the second step. But what is the difficulty? Try to understand. The difficulty is that too small a patch fails to be sensitive to non-local feature of the texture. Fine. Where the very large patch leads to enormous feature vectors. But why we are using algorithm or tools or machine learning algorithm or image processing algorithm? We are using it to get small patches as well, complex information as well. So this will lead to a computational problem associated with very high dimensional pattern recognition. Fine. So it can be done through it, but we have to take care of things like parameters, like threshold values and everything. And how we will set the threshold value? It can be random, hit and trial approach. We have to check it by one, by changing it. Fine. So there are different texture features approach. Different. We can use ROI, reason of interest. I told you that when there is a 3 gray levels are represented by numerical values from 1 to 3. I want to tell you, you can see all the images used here are black and white images. Can you see that? You can ask me why it is black and white only. How, I mean, we can work on some colorful image in RGB form. Red, blue, green combination. Fine. So any tool basically which has been processed through a computer will understand only 0 and 1. So the image can be processed, cannot be 3D. It should have to be 2D. And when it is 2D or when it is grayscale, it has to be 0 or 1. अगर black and white है तो या तो black वाला 0 होगा और white वाला 1 होगा. अगर मान लो ग्रे स्केल है, जैसे ये दिख रहा है आपको, बैकग्राउंड ब्लैक है और ये वाला ग्रे स्केल है, तो इट विल लाइज बिटवीन 0 and 1. Fine. So anything you will then apply, like Geber filter or anything, it will work on the reason of interest. You can see it here also. एक पर्टिकुलर डोमेन लिया, यहां पे देखो, इस डोमेन का एक मैट्रिक्स निकाला, and to get retrieve those matrix, and then we are having a matrix, and then we are particularly placed a centroid pixel, then neighborhood of a pixel concept will be applied. So what we are doing basically is consider a texture around the pixel of interest, and the texture characteristics based on estimation of conditional probability. I told you that it is based on random hit and trial approach of the pixel. So then there is an original image, and then there is a co-occurrence, when how those feature vectors are dependent or relatable to each other. And if it is independent, how it can be processed. अगर मान लो कि यहाँ पे कोई दिक्कत होती है, जैसे मैंने कल SBM बताया था, if it is a cross referencing, the distance, the decision line is cross referencing, then the margin will be small, and then they may mislead, they may not, they will definitely mislead the data, and finally we are getting a misclassification error for sure. So we are here playing with the matrix, we are here playing with the digits, we are here playing with the information which has been retrieved from input image. Fine. So this is the point we need to discuss about texture analysis. So we can take some examples of case study also. Fine. So we will discuss it in the next slide also. This has been done by Heraldic texture feature. He has taken some feature in gray level distribution. Fine. And why it has been taken in gray level distribution, I have also discussed. Fine. Then we have to energy measure of each signal or each feature vector. Fine. Then we have to take local contrast of each image of that particular segmented part. Fine. And then we have to measure the homogeneity of the image and how the data pixels are dependent or independent from each other. अब इसके नीचे कंसेप्ट आता है सम एवरेज. वो क्यों? वो इसलिए आता है क्योंकि क्लासिफिकेशन एरर नहीं हो. Suppose a same person with having mustache or a same person without having mustache can be detected as different person in image analysis or in face recognition or in object recognition. So how it will be, avoid? So we have to go through with the concept of variance, covariance, and so on. What I have discussed with you 10 or 15 slides before. And there is a concept called variance. Estimate the variance of gray level distribution. It has to be calculated. Otherwise 2 to 1 and 3 to 0, both data are the same image. And a person having mustache and a person without having mustache and the same person is there can be detected as a different person. So what is the point of using algorithm and image processing algorithm? Fine. So what we are going through with, we are going through with machine learning approach. Fine. which is a subset of AI. And image processing is also a subset of AI, computer vision as well. So we have to discuss current role. These are the examples of textual analysis, whether it is kidney stone or anything. It has been taken from IEEE. Lever segmentation. One thing you can focus on, that whether any kind of image it is, or whether any kind of algorithm you are applying, we are doing the same basic thing. So we need to clear our basics about it. If we have our basics clear, then we can proceed further with any kind of disease data sets or any kind of data sets we are having. Fine. So there are different scenarios in which, due to different algorithm, the recognition rate or the efficiency rate has been decreased or increased. Suppose we are having 5 image or 10 image and we are recognizing 5 images correctly, then we are having classification error of 50%, or we are having efficiency of recognition is also 50%. Getting my point? So this is dependable upon the algorithm we are using or the modeling of and the training consequences you are doing to your model. Fine. So there are 2 things which decide these things: how well the feature has been selected. I have written how well the feature has been selected to describe the tissue, but it is not about tissue only. It could be anything which has been targeted. The second point is how well the study group reflects the overall target patient population for the corresponding diagnosis. Fine. So we have to go through with variance covariance technique. How much data has been deviated? We have to find out the deviation also. That is called the patient population for the corresponding diagnosis. Fine. So we need to have some ethical information to go further with. Always remember that. So this is a very critical challenge. I would like to add something into it, which is the current role of AI in radiation ontology. Fine. The futures. So I would like to add future only, and then you can ask your question. Just the last slide, which has not been added. I mean, suppose we are having 2 challenges need to be resolved before AI can be more widely implemented in medical imaging. Fine. The first challenge is how to organize and pre-process data generated from different institutions. Every institution is generating the things based on some different attributes. So how we can associate those data to each other? How we can apply some rule which has not been compatible with particular data we are having? Fine. So this is the first challenge. Then challenges in summarizing and representing the patient data. This could be the another one. How we can summarize and representing the patient data. Fine. And practice of any other algorithm like predictive modeling using, health record is not much effective. It can be, having some flaws. So different researcher has presented novel supervised deep feature learning method, because there is a deep learning now, which has been very much effective to derive general purpose patient representation. Fine. So if we are having large scale data, our problem can be solved much more effectively and the result can be optimized for any specific task. This can be one of the solution. Fine, this can be one of the solution. So all these will need to addressed when pre-processing of data is being done. So most probably whenever you are working on some kind of things like that, which we have discussed, we need to focus on the pre-processing of the data. Secondly, how to encourage more image data sharing is also a challenge. Fine, we don't have that much. Even if we are going for corona test or on GIT hub, we are having pneumonia patient set and corona data set around 50 only. So if it would be like 500 or 600 minimum, the result can be more evaluated, the result can be more efficient. So currently image data sharing is very limited, which is one of the challenge. So the medical data security need to work on this with emerging need of data sharing. Data sharing is very much important, otherwise researchers cannot work on. So on a long run, how AI can become true, because I have told you that it should be the future, it is not the present. And it can really become truly intelligent without based on some intelligent system at human level. So it is the key question, if AI can replace human in medical imaging. That's the whole summary of what I have discussed with you. Can AI replace human in medical imaging? Unlike pure quantitative task, the knowledge evolved in medical imaging related, decision making require life experience and philosophy. Fine, it is a different thing. But for the machine to behave in a human level, there are not only challenges on data collection and algorithm, but also on ethical regulation. Regulation like moral values and sentiments and emotional intelligence, different other things. Fine. So this would be a question somehow that is also relatable. So when we are discussing this image processing, we have to make sure that we have to do some practical out of it. So we can see that how image is getting done and how image is getting processed in a tool. So we will do the maximum practical part tomorrow. We will start it from doing practical and practical and practical only. We will discuss much question, we will practice it and we will perform it. And you can see it practically as well. That's I am hoping for. Up to you for your questions. If there is any, please ask. Thank you very much.
Thank you, sir. So
Thank you,
participants, if you have any questions, then please ask to Abhishek, sir. Anyone? Anyone from the participants, you wish to ask something related to this lecture today?
There is a question, sir. Okay, there is acknowledgement only. We can have much more questions tomorrow when we will have some MATLAB thing. I want to discuss with you one thing. Let me share this screen, Himanshu sir, for
Yes,
2
sir.
minutes only. 2 minutes only. The thing is, if we don't have MATLAB tool in our box, we are having something. MATLAB can be, run on a browser itself. So MATLAB online, you have to type online compiler. You can see it, and you have to make an account through your domain, like your college domain or something. So there is a point, I have make it through IEEE domain, and you have to click it, and you will get MATLAB online thing. So you need not to install it even if you are doing it, but could be some cases like if I am working on some it is getting worked. So when we are working on some tool like which has been it is 2020, so it won't run the things which has been done on 2007 version. So whatever I will do, I can share with Himanshu sir, and he will share if you are interested in it. Fine, or you can contact me directly also, so we can discuss it more thoroughly tomorrow. Fine. So this is one of the aspect. We can work on the online browser of MATLAB, and it is working. If you can see, for example, I am read if we am writing, and just for checking it, and if I am writing so you can see it has done the classification also, and matrix form में हमारे पास data आ चुका है. So if we want to show it, I am show, or if we can write it again, onion.png, but we have to make it assigned to some. I just want to show you whether it is working or not. Fine. And we have to reach at second level, and then we are showing I am show. It is working normally. I have checked with it. There is no issue with it. A. So there is no point, I mean, we are having to face. So here is the figure. Getting my point? So everything has been done on this only. We need not to install it, even if you are not having this tool. So we can work on the online compiler. So this is one of the thing. Apart from that, we can do other stuff also. So you just need to see the things what I mean, give demo of tomorrow.
Okay,
Thank you very
Abhishek,
much.
we received yesterday one question that
Yeah,
we must have the knowledge of Python.
yeah.
The similar ways R is also same, but
Mhm.
we have the Python on which we use Python to run. Like there is a Jupyter notebook, or
Yeah.
you showed recently the
Mhm.
MATLAB, or
Mhm.
maybe there are some more things
Yeah.
from where we can implement the Python.
See, as far as classification and visualization is concerned, we can go with Python. Fine, we can go. अगर आपको deep learning algorithm, क्योंकि Python का जो learning ability है, उसके टक्कर में कोई भी नहीं है. Python has ability to, I mean, turn mountain also. Fine. बट अगर आपको कोई छोटा केस स्टडी करना है या फिर छोटे लेवल पे काम करना है तो देन OpenCV and MATLAB is much more preferable. But if you want to Python, then I mean Jupyter is fine to go further with. There is no issue with that. I have worked on
We
that
can do
also.
a Python coding on MATLAB also.
No, 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 no. It is not preferable, sir.
Okay.
Okay. Yeah.
Okay, thank you very much. I
Thank you,
hope
sir.
there is no question, and
Thank you, sir.
it was also very wonderful sessions. The PhD scholar and students will definitely get the benefit, and they definitely apply the knowledge gaining today in his or her research or study, and get some definitely good output. So, student participants, do not worry about the attendance. I will already taken the attendance and record in my database. So, attendance is already taken, Tanvi. So, apart from that, any question from the participants? We are going to close our second session. Any any question from the participant related to the image processing or MATLAB or Python or something like that? Okay, Abhishek sir, I hope there is a no question.
Okay,
Uh,
sir. Thank
so we
you.
can wind up the session now.
As you will say, sir. It's up to you.
Okay, sure. Thank you, sir.
Thank
So
you.
thank you
Thank you.
very much.
Thank you
See
so
you
much, sir.
sometime in the next. I think it is your last session tomorrow.
Yeah, that will
So,
be the last session. Exactly.
please, participant, be ready with your question if you have, or you can. I will also provide the mails of our expert. You can directly ask to the questions. So thank you, sir, Abhishek, sir.
Thank you, sir. Thanks again. Thank you so
Okay.
much.
Thank you, sir. Thank you. So participants, we have the next session at 1:30 a.m. 1:30 p.m. by the our expert Dr. Deepak Mittal. He is one of the expert from industry and currently working as a data science machine learning engineer. So session was very interesting. So keep login, or you can log out and log in again with the same link. We can meet again at 1:30. Okay. So see you there. Bye.